Today we are going to discuss about dynamic programming. In this one, we're discussing about general method. Myself, Dr. M. Purushotham Reddy, Associate Professor and Head of the Department of Information Technology. So, what are the course objectives of this course? The course objectives are students will try to learn mathematical approach for analysis of algorithms, methods and techniques for analyzing the correctness and resource requirement of algorithms, different paradigms of algorithm design, including recursive algorithms, divide and conquer algorithms, dynamic programming, greedy algorithms, backtracking, branch and bound, and graph algorithms. Strategies for solving problems not solvable in polynomial time. So here the course outcome with respect to this unit is, after successful completion of this course, students will be able to apply dynamic programming algorithms for calculating optimized solutions. Now we come to dynamic programming. In this slide, mainly we're discussing about what is meant by dynamic programming. Dynamic programming is a general algorithm design technique for solving problems defined by or formulated as recurrences with overlapping sub-instances. Dynamic programming means it is a designing technique for solving problems defined by or formulated as recurrences with overlapping sub-instances. This dynamic programming invented by American mathematician Richard Bellman in the 1950s to solve optimization problems. So what is the main idea to introduce this dynamic programming is set up a recurrence relating a solution to a large instance to solutions of some smaller instances. Next here, solve smaller instances once, record solutions in a table, extract solution to the initial instance from that table. So this is meant by dynamic programming. So once again, repeating this one, dynamic programming is a general algorithm design technique for solving problems formulated as recurrences with overlapping the instances. This one invented by American mathematician Richard Bellman in the 1950s to solve optimization problems. The main idea behind this introducing this dynamic programming is set up a recurrence relating a solution to a large instance to a solution of some smaller instances. Record the solutions in the form of table, solve smaller instances at a time, extract solution to the initial instance from that table. So applicable when subproblems are not independent. So this dynamic programming, it is applicable whenever the subproblems are not independent. Subproblems share sub-problems. So now here we see that NCK equal to, I will write it as n minus 1 ck plus n minus 1 ck minus 1. NC1 equal to 1, NCN equal to n. So once again, NCK we write it as n minus 1 ck plus n minus 1 ck minus 1. NC1 value is 1, NCN value is 1. Divide and conquer approach would repeatedly solve the common subproblems. Dynamic programming solve every subproblem just once and store the answer in a table. So in divide and conquer, here repeatedly we solve the subproblem, whereas in dynamic programming, every subproblem just once we solve and record the answer in a table. Next, so dynamic programming. This dynamic programming mainly used for optimization problems to find the solution of that optimization problems. A set of choices must be made to get a optimal solution. Here, first of all, we made a set of choices to get the optimal solution. Find a solution if the optimal value, that value is either maximum or minimum. There may be many solutions that lead to an optimal value. Our goal mainly is to find the optimal solution. So in this dynamic programming, first of all, we set many choices for finding the optimal solution. Here, find the solution with the optimal value, whether it is maximized or minimized depending on the problem. There may be many solutions that lead to an optimal value. So all that solutions are called as feasible solutions. All that solutions are called as feasible solutions. So from these feasible solutions, we choose the best solution. That solution is called as optimal solution. Next here, dynamic programming characteristics. Here the characteristics are characterize the structure of an optimal solution. First here, we characterize the structure of an optimal solution. Recursively define the value of optimal solution. Recursively define the value of optimal solution means here recursively we call the function and we solve the sub problem and we find the solution of that problem. Compute the value of an optimal solution in a bottom-up fashion. So here in this dynamic programming, we solve the problem in bottom-up fashion. So bottom to top, we solve the problem, we finally find the solution. Construct an optimal solution from computed information. So here constructed optimal solution from the computed information. Now we come to dynamic programming algorithm. An algorithm design method that can be used when the solution to a problem may be viewed as the result of sequence of decisions. An algorithm design method that can be used when the solution may be is in the form of result of sequence of decisions. In that situations, we are using this dynamic programming. Dynamic programming algorithm store results or solutions for sub problems and looks them up rather than recomputing them when it needs later to solve larger sub problems. Typically applied to optimization problems. So dynamic programming, mainly dynamic programming, it is a design method. This one is used to solve the problem that is in the form of a result of sequence of decisions. Dynamic programming algorithm store the results or solutions for small sub problems and looks them up rather than recomputing them when it needs to later to solve large sub problems. This dynamic programming mainly used to solve optimization problems. Next, principle of optimality. An optimal sequence of decisions that has the property that whatever the initial state and in the decision are, the remaining decisions must constitute an optimal decision sequence with regard to the state resulting from the first decision. So here the principle of optimality means the optimal sequence of decisions that have the property whatever the initial state, what are the remaining decisions who must constitute in the optimal decision sequence with regard to the state resulting from the first decision. This one is called as principle of optimality. Essentially, these principles state that optimal solution for a large subproblem contains an optimal solution for a smaller subproblems. So once again, listen. So the optimal sequence of decision has the property that whatever the initial state, what are the remaining decisions must constitute in the optimal decision sequence that results from the first decision, that state resulting from the fast decision. These principles state the optimal solution for a large subproblem contains an optimal solution for smaller subproblems. Just what is the difference between greedy method and dynamic programming? Here, this greedy method, this greedy method, it is also used to solve optimization problems. It is also used to solve optimization problems. So, but here in this greedy method, only one decision sequence ever is generated. So, in this greedy method, only one decision sequence is ever generated. And greedy method is a top-down approach. Top-down approach. Here in this greedy method, we solve the problem in top-down, from top to bottom, and finally we find the solution of the given optimization problem. In this greedy method, mainly we solve the problems like as fractional knapsack problem, that minimum spanning trees. So find the solution of the spanning trees, minimum spanning trees using Prim's and Kruskal's algorithm. So in that one, we see that we solve the problem in the form of top-down approach. Next, we come to dynamic programming. In dynamic programming, in this dynamic programming, here we solve the problems which has in the form of sequence of decisions. That's why here we say that many decision sequences may be generated. This dynamic programming approach, it is mainly used to solve optimization problems. And also here in this dynamic programming, it follows the bottom-up approach. So here we solve the problem from bottom to top. That means here in this dynamic programming approach, we come back to the previous problem. Again, we solve that one. That one is also done in this dynamic programming. This dynamic programming mainly used to find the optimum solution or optimal solution of the given optimization problem. This dynamic programming, it gives the more optimum value than comparing with greedy method. So once again, listen this one. Greedy method generally used to solve optimization problem. It follows top-down approach. Here, this greedy method mainly solve one decision sequence is ever generated. In this greedy method, mainly we solve the problems like as fractional knapsack problem, minimum spanning trees by using Prim's and Kruskal's algorithm, etc. So in that methods, we observe that we solve that problems from top to bottom. So and also find the optimum solution. In greedy method, we are not come back to previous stage, and also again we solve the previous stage. That is not possible in greedy method. We come to dynamic programming. Dynamic programming is used in the situation where we have many decisions and also the subproblems may are not independent. In that situations, we use this dynamic programming. Dynamic programming is also used to solve optimization problems. It follows bottom-up approach. It solves the problem from bottom to top. In this dynamic programming, mainly we solve the problems like as 0-1 knapsack problem, matrix chain multiplication. So matrix chain multiplication, and also we solve optimal binary search trees, traveling salesperson problems, All these type of problems will solve under this dynamic programming. Next, what is the difference between dynamic programming and divide and conquer? So here, this divide and conquer mainly used to solve the problems which are independent subproblems. That means here in this divide and conquer mainly we divide the problems into subproblems. We recursively solve all the subproblems and combine the solutions of subproblems to get the solution of the original problem. That means here in this dynamic programming, the problems which are divisible into subproblems, that type of problems we solve only in divide and conquer. Divide and conquer problems are top-down approach problems. That means in top-down approach only we solve the problems in divide and conquer. In divide and conquer, we solve the problems and finally we get a solution. That is only feasible solution. It is not optimal solution in divide and conquer. We come to dynamic programming. Dynamic programming mainly used to solve the optimization problems. Here also the problems which are the subproblems which are independent. So which are not independent. That means which are dependent. That type of problems we solve in this dynamic programming. And also here every sub problems we solve only once and save the answer in a table in dynamic programming. And also here we are avoiding the work of recomputing the answer every time. The dynamic program mainly in this dynamic programming mainly we solve the problem depending on the approach, bottom up approach. This dynamic programming mainly used to solve the problems and produce the optimum solution. So these are the differences between the divide and conquer and dynamic programming approach. Once again, listen. In this divide and conquer, we follow the top-down approach. Here in divide and conquer, mainly the problem divided into subproblems which are independent. These subproblems solve recursively and then combine the solutions of all the subproblems who find the solution of the original problem. Here in divide and conquer, may or may not get the optimum solution. This divide and conquer mainly applied the problems which are divisible into subproblems. For example, like as binary search, med sort, quick sort. This type of problems will solve under this divide and conquer. Next, we come to dynamic programming. Dynamic programming mainly solve the subproblems which are not independent. And also here in this dynamic programming, we solve the subproblems only once and saves its answer in a table to avoiding the work of recomputing the answer every time. In this dynamic program, mainly we solve the problems in the fashion of bottom-up approach. This dynamic programming gives optimal solution. So dynamic programming gives the good more optimal value comparing with divide and conquer. In this dynamic programming, mainly we solve the problems like as matrix chain multiplication, optimal binary search trees, traveling salesperson problem, 0-1 knapsack problem. All these different types of problems we solve under this dynamic programming. These are the differences between dynamic programming and divide and conquer. So this is what is meant by dynamic programming. What are the differences between divide and conquer? What are the differences between greedy method and dynamic programming? That is defined in this session. Thanks to everyone.
Like, share and subscribe. Hit the bell icon for more updates.